In this video, I will show you an AC circuit example using supermesh analysis. This is the reference for the given circuit. Practice problem 10.4, book Fundamentals of Electric Circuits, Alexander and Sadiku. There is no solution given in the book for this circuit. From the circuit shown in the following figure, determine the current I naught using supermesh analysis. This is our given network. I notice the current that is flowing through this path. Now see, we have to use supermesh analysis here. If you look at this mesh and this mesh, between these two meshes we have this current source of 2 phase angle 0 degree ampere, and we do not have any other current source in their outer loop, so they will form super mesh. At first, let me identify the meshes in the network. Let's say this is point A, this is B, this is C, this is D, this is E, this is F. Now see, this A, B, C, E, F, A, B, C, E, F, A will form mesh 1. This B, D, C, B, B, D, C, B will form mesh 2. This D, E, C, D or C, D, E, C, C, D, E, C will form mesh 3, and between mesh 2 and mesh 3 we have this current source of 2 phase angle 0 degree ampere, and we do not have any other current source in their outer loop, so mesh 2 and 3 form super mesh. How do we indicate the super mesh in a network? We replace the current source with open circuit and we merge the two meshes that are sharing that current source. So if I replace the current source with open circuit and merge mesh 2 and mesh 3, I will get the area shaded by this rectangle, and that will be our super mesh. The mesh 2 and mesh 3 will form the super mesh after replacing the current source with open circuit. So super mesh will be the B, D, E, C, B, this loop. Okay, this is our super mesh. Analysis of super mesh AC circuit is quite similar to the analysis of super mesh with DC quantities. So here mesh 2 and mesh 3 will form the super mesh. Let's say in mesh 1 we have the mesh current I1 that is flowing in clockwise direction. In mesh 2 we have the mesh current I2 that is also flowing in the clockwise direction, and mesh 3 has current I3 that is also flowing in the clockwise direction. Now look at the node D. In node D the current I2 is entering, I3 is outgoing. We have this 2 phase angle 0 degree current entering. So if I apply Kirchhoff's current law, at node D, you have to remember that all the quantities are phasor quantities. I will get I3 is equal to I2 plus 2 phase angle 0 degree or I2 plus 2. This will be our equation number 1. After applying Kirchhoff's current law at this node, we will apply Kirchhoff's voltage law around the super mesh, and this is our super mesh. Okay, if I apply Kirchhoff's voltage law around super mesh, I will get minus 5 I3 minus I1 minus J4 I2 minus I1 minus J8 into I2 minus J6 into I3. This will be equal to 0. So if I apply KVL around the supermesh, I will get minus 5 I3 minus I1 minus J4 I2 minus I1 minus J8 I2 minus J6 I3. If I separate out the coefficients of I1, I2 and I3, I will get minus 5 I3 plus 5 I1 plus J4 I2 minus J4 I1 minus J8 I2 plus J6 I3. Now see, if I separate out the coefficients of I1, I2 and I3, I will get 5 minus J4 I1 minus J4 I2 minus 5 minus J6 I3 equal to 0. From equation number 1, we know that I3 is equal to I2 plus 2. So if I replace I3 with I2 plus 2, I will get 5 minus J4 I1 plus minus 5 plus J2 I2 equal to 10 minus J2, or in polar form it will be 15.62. Phase angle will be minus 50.2 degree. This will be equation number 2. Okay, this is equation number 2. Now see, we did not work out with mesh number 1. After applying KVL around the super mesh, we will apply KVL in all the loops that is outside the super mesh. So here we have this loop 1 or mesh 1 that is outside the super mesh, and we did not work out with this. Now I will apply KVL in mesh 1 in phasor form. So if I apply KVL in mesh 1 in phasor form, I will get plus 50 minus 10 I1 minus J4 I1 minus I2 minus 5 I1 minus I3. That will be equal to 0. So if I apply KVL in mesh 1, I will get this equation. If I separate out the coefficients of I1, I2 and I3, I will get 15 minus J4 I1 plus J4 I2 minus 5 I3 equal to 50. Phase angle 0 degree. From equation number 1, we know that I3 is equal to I2 plus 2. If I put the value of I3 here, I will get 15 minus J4 I1 plus 5 minus J4 I2 equal to 60. Phase angle 0 degree. This will be our equation number 3. So we have equation number 2 and equation number 3 here. This is equation number 2, where the coefficient of I1 is 5 minus J4. The coefficient of I2 is minus 5 plus J2. If I write down equation matrix form, I will get 5 minus J2. Here I will get minus 5 plus J2, I1, I2. In the right side, I will get 15.62. Phase angle will be minus 50.2 degree. From equation number 3, I will get 15 minus J4. Here I will get minus 5 plus J4, I1, I2. Here I will get 60. Phase angle 0 degree. So these are the equations in matrix form. Now see, we have to calculate the current I0 from this network. I0 is the current that is flowing through this AB path, and from the circuit it is evident that I0 is the current that is actually flowing in the mesh 1, or I0 is equal to I1. So we have the equations in matrix form. We know that we can calculate I1 and I2 by using Cramer's rule. To use Cramer's rule, at first I have to find out the determinant of coefficient, that means D, and I have to calculate the determinant of coefficients of current I1, that means D1. So how do we form the determinant D? We will take the coefficients of I1, let's say I denote that with A1 and A2 in one column, A1, A2. In another column I will take the coefficients of I2, let's say I am denoting that with B1 and B2, that will be equal to B1, B2. If I cross multiply this, I will get A1 B2 minus A2 B1. And how do we form the determinant D1? We will replace the column of I1 coefficients with the constants in the right side, C1 and C2. Therefore this will be C1, C2. In this column I will get B1, B2. If I cross multiply this, I will get C1 B2 minus B1 C2. So if I form the determinants, I will get determinant of coefficients, that is D will be equal to 5 minus J4, 15 minus J4. Here I will get minus 5 plus J2 minus 5 plus J4. If I multiply this one with this and take the minus of the multiplication of this with this, I will get 58.86. Phase angle will be minus 9.78 degree. Now see, determinant of coefficients of I1, that is D1 will be equal to, here I will replace this column with the coefficients in the right side. This will be C1 and this will be C2. This will be B1, this will be B2. If I cross multiply this, I will get C1 B2 minus B1 C2, that will be equal to 298.65 with phase angle minus 3.84 degree. Now see, the current I0 is the mesh current I1, and we can calculate the mesh current I1 by dividing the determinant of coefficients of I1 D1 with determinant of coefficient D. If I do that, I will get that will be equal to 5.074 with phase angle 5.94 degree ampere. This indicates that in the circuit the current I1, the magnitude of current I1 or I0 will be equal to 5.074 ampere, and the phase angle of current will be leading at an angle of 5.94 degree to the applied voltage in the circuit.